Hello students. So last class we discussed about pointers and we continue with pointers. So I already talked about pointers and functions. So where again we'll discuss these pointers with the functions. Okay. So let us learn about what is function and what relation exists between these pointers and functions. So already we know that what is function means. Function is a set of statements, or it's a named unit of program statement designed to perform a specific task, and sometimes it returns a value. Most of the time, so it's used to invoke the function by sending some argument and returns a value. So there is a close relation between the pointers and functions. So we know that function uses arguments in order to carry its assignment. The arguments are usually provided to the function when necessary. A function is also declares its own variables to get the desired return value. Sometimes, whenever we pass some arguments to the functions means the function will accept. So that's assigning the values from a calling function to the called function. So that's why arguments we have usually provided to the functions and when necessary. So whenever a function needs some arguments means we are supplying. So that will be assigned. How it is assigned means that is whenever there is the actual and formal parameters already we have discussed. And also you can see the function could also declare its own variables to get the desired return value. Sometimes function is returning value means the same value may not be. It creates one or more variables, and final value can also be returned through the function. So like other variables what we are discussing so far already, similarly pointer can also be provided to the function. That's a more important. So can we pass the pointers to the functions? Already we know, we haven't discussed. Let us continue this. Yes, pointers can be provided to the functions with some different. There is some few rules we call this. So there is some restriction. There is some way of accessing pointers. That is, normally they differ in normal variable. That's why whenever we declaring function that takes a pointer as an argument, so make sure we use asterisk symbol. So that is how it is differentiate between normal variable and pointer variables. So whenever function is you're declaring means, or maybe prototype. So there what happens, we have to mention this asterisk symbol. So for each arguments, that is whenever you're passing pointers as arguments, then each arguments must accept this asterisk. We'll see this one how it works. So when calling to the function uses the reference to the variables. What actually it does means, so it will not create one more variable. So it takes the references to the variables. The function will perform its assignment on the referenced variable. So that is how we get the address of this arguments, and that reference will be copied to the arguments that is inside the function. So then using that we can perform any operation. So whatever we make the operations with the arguments will be affecting the actual arguments. That is indirectly we do not create one more different variables. But what we have means the same reference we are taking, hence whatever you work with the actual argument will be affected through the formal arguments. So that is what the relation between pointers and functions. So whenever we use a pointers means whenever we declare pointers, so the asterisk is necessary, and whenever we call the function, so to pass the address we use this address operator. You can see that calling the function we use the address operator. So when you're declaring the function we use the asterisk symbol. We'll see this one how it works. We'll take an example also, we'll understand. I think already you are familiar with. Let me once again we'll go with the program segment, or let us complete programs, we'll understand. So there are two methods of invoking functions. So we have a call by reference and one more is call by pointers. We have one more last academic we have discussed this call by value mechanism. So where the values are being sent. So here what we are trying to do means we are sending the references and also we are sending the pointers. So whenever function call is made, so we send the values. That is what we have discussed here. Let us learn the sending the references, how we can work with the reference. Again, it's address, alias names, another names, and let us see how with the pointers. As we know, pointer contains the address of other variables. How this other variable in here, in this case, it becomes actual argument, and the pointer becomes a formal argument. So that we'll see that you'll understand how it works. We'll go with the first one, pass by reference method. So when the parameters are passed to the functions by reference, so whenever we pass the parameters to the functions by reference technique, the formal argument, that is the function definition, the formal arguments or formal parameters will become a reference to the actual argument. So whatever we declare, I'll show you that one. What are the formal argument? What are the actual arguments? So these actual argument means function call. When you call from the main program, you are sending along with the function name some values are called actual arguments. So these arguments will have the reference by the formal argument, that is a function definition will have, if it is x, something like AB means, so we have a xy. This AB are referred by x and y. So therefore, whatever you make changes, you are not making to this variable x and y. You are actually making the changes to the a and b. We'll see that one how it works. So in the calling function, this means that invoking the called function does not create its own copy of original values. That's very important. So it will not create its own original values. What it does means, so rather than it refers to the original values by different names. That's what I talked about. So already I've told you, also will understand this one. That is their references. Thus the called function works with the original value, and any changes you made that get reflected to the actual data. So that is how the call by reference works. In a call by reference method is normally useful, so where the values of original values are to be changed. It has to be modified using a function. So there is now it's the original values from the main function. This is a sub-program or sub-functions. Using this function we have to change, means I have to work with the actual values, then I have to go for call by reference. So for instance, function to be invoked that swap two variables that are passed by reference. We'll take an example. You can see we'll create a function used to swap, interchange the values of two variables. Now we use the reference, so that is invoked. It uses the technique of pass by references. We'll learn with the example, then you'll able to understand. So let us take a program to swap the values of two variables using pass by reference method. So you can see here, I have defined the function. You can see here, it's a swap function. So it is, we have a data type, we have address operators. It gives the address reference. And also you can see here, it's not like normal. So instead of variable name, it's called prototype. So we are using address operator. It's a reference. To get the references, we use this address operator. So these are normal variables, A and B. So whenever we create A here, okay, so we have a and also we have a B. So these two will be, A is 10 and B is 30, something we created A and B. And let us display what is A. So it is 10 will be displayed. What is B? B equals 30 is displayed. Then we call the function. When the function is called, so the control transferred to here swap. So this is a function name and it is transferred. You can see here we have declared variable X and we have a variable Y. And look at this part, so it is a reference. So reference of A. So it is indirectly you're matching. So whenever assignment takes place here, so address of A, that is what is A, so its reference will be copied. So X as a reference of A. Similarly B, Y as a reference of B. So indirectly, so X and Y are referring to the same variable A and B by another names. So that is why we use the reference. So data type you can see here, reference of that X gets the reference, address of A. Similarly, reference of B as the Y. So now we are changing. So it's like normal. X is the same variable name A. And we have a Y which is the same variable name B. So now this temporary is a one more variable. So where we copy X to, so it is, I think no need to explain this, already we know. So it is copied to temp and X becomes vacant. So there we copy Y and then again transfer. So here what happens, X and Y are interchanged. So indirectly X and Y are the names of the same variable AB. So hence AB is also interchanged. So after this we'll come back to the function and we display value after swapping. You can see, so A becomes 30 and B becomes 10. So that's how this function works. So this is the call by reference technique. This is how it works in call by reference technique. So similar way, what you can see here, the original values A is 10 and B is 30. So after swapping, already I've explained, so it becomes 30 and so on. So this is how this call by reference mechanism works. So in similar way, So we can also invoke the function by sending the what we call addresses, that is the pointers. So you can use the pointers, and instead of this references, let me take the what we call the pointers. Pointers also contains address. So using that address, we'll see how it works. So we'll discuss about the invoking functions by passing the pointers. So this by passing the pointers we'll discuss. So when a pointers are passed to the function, that is, a pointer means address of the actual arguments in the calling functions are copied to the formal arguments of the called function. So that is, we are working with the addresses. When the points are we are sending means, that is, you are invoking, we are calling the function call will have the pointers, and the receiving, the formal arguments of the function definition will take the argument that's also addresses. So now both are working with the as a pointers. So whenever we work with the pointers, there are already I have discussed, we have to use the asterisk star symbol whenever we call the function. So as usual, what happens in the called function, so we can make changes to the actual arguments of the calling function. Therefore, here also the called function does not create one copy of the original values. So rather it refers to the original values by the addresses passed through the pointers, that is, which is received through. Normally what happens here, we'll take an example, you'll understand. So here what happens, whenever we call the function, we are sending the address of A and B, where A and B are actual arguments. So these will be passed to the formal argument, to the function. That function, instead of creating the copy of A and B, it get the address of A and address of B by another variables like pointers. Now we are using X and Y. So hence, whatever you make changes using the function, inside the function, using the pointers like formal arguments X and Y, that directly operating on the actual arguments A and B. So that will be explained with this program. You can see here. So we have a program. This also sometimes they ask, write a program to swap the values of two variables using it's a pointers method. You call by pass by pointers method. So we have to change this. It's a pass by pointers method. So now you can see function prototypes. So whenever I define function prototype means return type specifier, function name, and list of arguments with data type. So you can see here I'm using data type, it's a pointer, so integer pointer. Similarly, you can see star before the variable name. So they are indicating X and Y can hold the address of integer variable. Any type of integer. So that is X means now X can contain the address of any integer variable. So Y means Y is also variable which can store only address of any integer variables in the future. Now let us define normal variables. A is 10, integer A, comma B equals, so initialized. And so you can also use C in, no problem. A is 10, B is similar to the previous program. The original values are, so after displaying, so A is A, that is 10. So B equals B. So these two are variables, that's why they are not enclosed in double quotes. So this is a string constant, it appears as it is. And also this is a string constant, it appears as it. So you can see here we have a and also we can have a B here, and then A value is 10 and B value is 30. So we have some address of A here and address of B here. So some address. We can also take here. Next, when you call the function, you can see here I am calling the function. So when I calling the function, look at this. A is a normal variable and it gives the address of A. And also you can see here, so here we have an address of B, that is, we get the address of B. And this will be passed. So now what is X? You can see here getting the address of A. What is Y here? You can see here it is getting the address of B. So thus now X and Y will contains address of A and address of B. So now we can use normal variable temp, and you can notice here I have used here star X. So whenever we talk about pointers, whenever I use a star means indirection operator, so it gives the value which is stored at that address. Now at that address we have the value A, and value A is copied to temp variable, and this becomes vacant. There we'll get the value of B, that is referred by Y. So now you can see, so these two are interchanged. Again in temp we are interchanged. So it's similar. Now you can understand this is using pointers, the values are interchanged. You can see here the original values are A is 10 and B is 30. And after the swapping, so here A is 30 and B is 10. You can see here they are interchanged. How it is done means it is using the pointers. You can see here the address of A will be copied to X, address of B will be copied to Y. So using the addresses, we are working with the values. That's how you can, swap the values of two variables using the pointer. This is how pointers and functions. Whenever we pass the arguments as a pointer to the function, this is how it works. So we have to pass the address, and then this using the address, this received, these are all called, A, B are called actual arguments, these are called formal arguments. So this is a pointer, this also pointer. So the actual arguments are referred, that is using the address of A, X. So here using address of A, this is the address of B. So using the addresses pointers, already we discussed, we can perform any operation. Here on a simple example to show that how using the addresses we can exchange the values of the variables. I think you have understood. This is one of the important programs, so you can learn this. So next one, the same thing they have explained. So whenever prototype we use means we use this asterisk symbol is very important. Whenever we call the function, we use the address AB because we have to pass the address. So now let us discuss something about a memory leak. So this is also similar to already we have discussed about memory leak. The same thing here, memory comes and memory goes. So already we have discussed whenever we go for dynamic memory allocation, if the memory allocated which is not deleted after its usage, it remain intact. So that is still it is occupied. So therefore it has to be released. So if you do not release, it produce orphan memory. When those orphan memory block increases, it has an adverse effect. Already we have discussed. So therefore it becomes necessary whenever the function finish its task, it has to be free the memory. If you do not do this means that is what the problem already we discussed. The same where the memory comes and memory must go. So we have to leave it again. We have to send it back. There is always complication, and this one could become a quite serious. Although it's a very easy remedy, the problem is that all the memory that you allocate using dynamic memory allocation conveniently left intact, it actually never gets deleted. That's what very important. So it never gets deleted automatically. That is, the memory will stay allocated. It will be stay allocated until you tell the computer that you have finished with it. So I finished, I don't want. The upshot of this, that's the drawback of this, is that if you don't tell the computer that you are finished with the memory, it will be wasting the space that other application or other parts of application could not be using this memory. This eventually leads to the system crash because where all the memory is occupied and there is no memory, that leads to the failure of systems. So through all the memory being used up, so it's pretty important freeing the memory. That's what very important. So the memory when you have finished with it, is you have to be released. Already I was using delete function, delete operator, it has to be released. That is what memory comes, and the memory should go back to the free store. So this is how memory comes and memory goes. It's a just you have to follow this. So what is memory comes means what is memory goes. Memory will not go automatically. So after a job is completed or you finished your task with that memory space, it has to be freed. How do you do this means using delete operators. Otherwise, it causes a lot of problem. What is the problem means? It takes up all the memory and keeps occupied. So nobody is using that memory. And you cannot use it by other part of the program as well. That leads to system crash. There is no space means we cannot perform any operation. That is the last memory storage is, we lose. There is no space. That's why it has to be freed. That is something about memory comes and memory goes. So we learn something about pointers and objects. Already we know about what is an object means, an instance of class. So what is a class means? Group of objects which have a similar behavior and characteristics. Already we discussed, I think, programming. So class, we have a data and also we have a member function. They are put together. So now when you create an instance of that class, and through this objects we can access the members of the class. That is, there are private members, there's the public members, and also protected members. So that is something about class. I think you know in much detail, so no need to explain further. I hope you can understand. So now we can see how we can we use a pointers to the object. Of course, we have discussed there are pointers to variables. We started with pointers and variables, and pointers and array we discussed. Then we discussed pointers and strings, and also we discussed pointers and structure. Similarly, there is a pointers to object as well. The pointers pointing to objects are referred by, or you can call it as a object pointers. That doesn't make difference, just you can call them. So how do you declare, pointer to objects means, so declaration of pointer to objects. How do you declare? Similarly, how you declare an object? How do you how do you declare an object means a class name followed by star followed by object name. That is the pointers when you use. Just to use the object means we don't use star. Exactly similar to normal variable, how pointer variables are declared. Here also same. So class name followed by star followed by object pointer. It's a name, any name you can give, any valid identifier. The class name is the name of the class that's already you defined, and object pointer is the pointer that you are creating an object of this type. So this pointer name, that's object pointer, can store the address of the data type called class name, that is what you define. So for example, you can see if there is already you defined with the employee with some data member and member function, this EPTR can store address of this employee objects in the future. And also when I will discuss structures, I talked about this one, that is using a star dot member. So you can use the arrow, hyphen and greater than symbol instead of dot operator. Already I have discussed what works with the structures is exactly similar way you can use. To access members, we use a star, then we have a pointer name, then we use a dot, then we have a member name. And similarly, when you have an object, so we have to accept the object by object name dot member. That's a data or function, member function or member data. To access through the pointers we use, instead of using star EPTR dot employee name, star something like that. So you can use EPTR arrow, then member name. So that's a simple, no problem, so you can understand. So let us, we take with example, you will understand, it will be much easier. You can see here, so now I am defining, you can see a class employee, and it consisting of 3 members. One is employee number, which is an integer type, and also we have a name, so which is a string, array of characters 20, it's a string name. Then we have a salary, which is a float variable. So these are 3 members which are private. Private means they can be accessed only within the class. If you want to access means outside is not possible. Private means only these members functions can access these values. They cannot be accessed from outside. Now let us, this is a class definition hence, so we have a function. So this is employee, and then this is the scope resolution operator. I think you're already familiar. That is to inform this function, get function is a member function that belongs to the class EMP. So, and it doesn't return anything. This function doesn't return anything. So we input normal, enter employee number. So we input employee number. That is, you are providing the value for the private member employee number, because get function is a member function of the same class. Similarly, name and similarly salary you supplied. So this is how you are assigning the values to the data members of the class EMP, employee. And let us take one more, is a displaying. The same values, we use a one more function, the same definition, return type specifier, class name, scope resolution operators, and then function name. It's not, I think you are familiar with these things. And then we'll come back to the display. So employee number is employee number, displaying the data members of the class. And similarly, okay, so you have, I think it's clear now, you have understood. There's no logic here, just input output. Already you are familiar with this, how input output operations are performed. So just we are displaying input and then displaying output. That's very simple. And this is the class. So we have defined class and its member function as well. So now we'll come to the function. So you can see here, this the first part, what we are trying to use is, we are using the object here. So E is an object of type class employee, EMP. And also you can see here, I have defined a pointer because star I'm using. So EP is a pointer to the data type that is called class EMP. So now this is exist and we have to copy the address. So this only defining, when you get the address of object, then you can say EP. Now you can use EP instead of E, where now this is a pointer to E after getting the address. So we have 2 member functions, one is get and display, which are the public member function, hence you can access from outside. So since it is involved pointers, I'm using instead of star ep.get function, I'm using arrow sign. Already I've explained this one. Similarly, ep.display. So it will display, when I call this function, it goes here and it performs this operation and it comes back. Similarly, when you call this function, it goes here and perform this operation, comes back. Next is we stop the program. You can see it is enter employee number, whatever you type, so it will be there, and employee name and the salary. This is using get function, this is created. Similarly, using a display function, so this will be displayed. So all this reason. So this is how pointers and object work. So for the class members, that's class members we have here in this example, employee number, employee name, employee salary, that could also be operated through the pointers. This is how it works. I think you have understood. And one more, we have every object in a C++ has access to its own address through the important pointer called this pointers. This pointer is an implicit parameter to all the member function. Therefore, inside a member function, this may use to refer to the invoking object. So what does this pointer means? Every function, every member function has an implicit parameter. So automatically there is a implicit parameter to all the functions, that is which is the member function of the class. So that is called this pointer. So this pointer is its address, its own address through the important pointer called this pointer. So what does this pointer means? In C++, every object like this you created, what we created E is an object, has access to its own address through an important pointer called this pointer. That is a pointer, like I've used this address and I made this pointers. By default, we have a what we call pointer. That pointer is called this pointer. So using this pointers, that is all the member function can be implicitly, that automatically you can access all the member function of the class. Therefore, inside a member function, this may be used to refer to the invoking object. So whenever we use them in declaring an object or invoking the object, means that also directly you can use this pointer. That is something about this pointer. So this completes this chapter. So I think you go with the 1 marks, 2 marks and 5 marks, question 3 marks questions, assignment you write, and keep the notes updated. Okay, so no problem. If I have a doubts, let me know that. Okay, so this completes the important chapter called pointers. Next we'll continue with other topics which we'll discuss, okay, next class. Okay.